and current scenario of COVID-19 as an IQAC initiative. Our college always promotes such kind of activities which are really useful for the society. We are glad to have very good response with around 1300 participants from India and abroad. We have researchers and students from countries like USA, Sweden, Algeria, Nepal, Iraq, Iran, Morocco, Taiwan, and around 15 different states of India. On behalf of IQAC, Haribhai V. Desai College and PG Department of Chemistry, I welcome the delegate speakers, Professor Dalaila Hameshi from Algeria and Dr. Swapnil Sonawre from Maharashtra, India. I again welcome you all for today's webinar, and I am sure that you will definitely enjoy this seminar. Thank you. Over to you, Vaishnavi Madam.
Thank you very much, sir, for giving such a basic information of polymers and regarding to webinar. Let's start the actual webinar with the introduction of our today's guest, Dr. Dalila ma'am. Now, Dr. Vikram Pandit will give introduction about our today's guest speaker, Dr. Dalila ma'am. Over to Dr. Vikram Pandit, sir.
Thank you, Vaishnavi ma'am. I'm here to present. Hello. I'm here to introduce Professor Dalila Hamechi. She's currently working as a professor in Faculty of Technology in Mirabejia University, Algeria. Her area of research interests are processing and structural property study of polymer composites, composite interfaces, thermoplastic composites, and nanocomposites. Also in natural rubber composites, nanoviscose, cellulose, and nanoclay. She published more than 60 indexed publications in various national and international journals. She is also a very active reviewer for many journals. With this brief introduction, now I request Professor Dalila to kindly guide us. Meanwhile, if participants have questions, they can put it in a chat box. After the lecture, we'll take the question and answer session. Thank you. Hello, ma'am.
Hello. Hello.
Yes, ma'am. Now you can share your screen. Please start the presentation.
It is okay. You can see my screen. Can you see my screen?
Not yet.
Yes,
Not yet, ma'am.
Yes. Now it's visible.
Okay. Can I start?
Yes, ma'am. You can start.
Okay, thank you. So, hello, everyone. I would like first of all to thank everyone for coming to this event today, and welcome. It's an honor to have the opportunity to take a side in this meeting, and it is great delight to have a formal partnership between us. And I have to say for Dr. Vikram Pandit, thank you so much for your invitation. Please let me start or introduce myself. I am Dr. Dalila Hamish from the University of Bijaya in Algeria. Bijaya is my town. It is situated in the north of Algeria. It is a large Berber-speaking city located on the edge of the Mediterranean Sea. The city is backed by the mountain of Gouraya. Gouraya is so beautiful here. So our university has 4 campuses. It is currently represented by 20 research laboratories, and I belong to Laboratoire des matériaux polymères avancés, Laboratory of Advanced Polymer Materials. My lead is Professor Mustafa Kassi. So my lab includes 4 research teams, totaling 45 researchers, including 20 PhD students. And my research team title is Study of Interfaces and Structure Properties, Relation of Polymeric Materials. My head is Professor Amar Boukerou, and also he is the Dean of our Faculty of Technology. Please let me start by saying just a few words about my research area. I provide courses for graduate and undergraduate and PhD students on interfaces science, adhesion, polymer composites, and also biopolymers. I am the author of around 60 papers in international journals about polymers and composites, 1 review, 3 books, and 2 chapter books. I have supervised around 8 PhD works, and I am a member of the Scientific Council and also the member of Ethics and Professional Conduct Committee. I am a project manager of more than 3 international projects. My research interests include interface science and nano and biocomposites. I am also involved in research on biopolymers and natural reinforcing agents for different applications. More generally, the development of new materials in biomedical application is one of the hot topics for me. I share with you some foreign collaborators from France, Spain, Morocco, Tunisia, Canada, and India. So let's start with our subject today. We will talk about, as you can see on the screen, our topic today is polymer. We will talk about polymer and the relationship between polymer and the pandemic COVID-19. Let's start by giving a simple definition. What is the definition of polymer? Polymer has 2 parts. The first one is poly, meaning match or many. The second one is mer, meaning parts or repeat of unit. It refers to a very large molecule structure chain, like in nature. It is macromolecules formed by the covalent attachment of a set of small molecules termed monomers. So how we can classify the polymers? In two classes. The first one is man-made or synthetic polymers that are synthesized in the laboratory, which we can say call a synthetic polymer. The second one is biological polymer that are found in nature, and it's called natural polymer. What about application of polymers? Polymers or plastics is everywhere in our life. And nowadays, polymers are used in almost all walks of life. For example, clothing, electronic, construction, and mostly in packaging. But today, we will be interested in the medical hygiene application. As I said, we will talk about the application of polymers in medical and hygiene application, and we will refer to COVID-19. When we ask people about polymers, what is the answer? The answer in the past few years, of course, more and more people have said that plastics should be banned and replaced with other materials. Why? because they think that the polymers pollute the environment. Of course, no. The plastics industry and the researchers must constantly defend against these arguments. Plastic don't pollute the environment, and their ecological footprint is one of the smallest compared to materials in general. Yeah, because it is a problem that many people don't understand what's polluting the environment means. They mix it with letting and don't know the meaning of ecological footprint. When the environmental, you should to know that when the environmental friendliness of a product is evaluated, life cycle assessment must be carried out. That means we can, before to manufacturing of the plastic materials, we can think about the life cycle assessment, and it must be which includes the whole recycling. Only in this way can the environmental friendliness of products be compared. Here I share with you two figures. The left one, it is the recycling process. It is the different steps to follow in order to recycle any plastic materials. Of course, it is not easy. I think the collection is easy, but the separation of polymer is difficult. But it is possible. It is not possible, impossible to recycle any polymers. And at the right, I show you the waste of PVC and how we can to get beautiful things from this waste. Here, for example, from PVC waste, we can get a Nico outdoor garden compounds, which is made from or with recycled PVC. And in my opinion, it is so beautiful to have like this garden. But fortunately, of course, this definition changed because in the past few months, plastics have been accused less because climate change has been in focus, and indeed they have a very significant role in reducing climate change. Here I give you one example. In the vehicles of transport application, you know that vehicles generally, many parts of vehicles is made with plastic. Yeah, we can replace the metal and the glass with plastics, and when we do it, the weight of vehicles decrease. And when the weight of vehicle decrease, that means that we will use less of fuel. And you know, when we use less of fuel, the emissions will be reduced. As you can see on these figures, effectively, the emission of CO2 is decreased after the decrease of the weight of vehicles. This is because the weight of vehicles decrease because we replace some parts of vehicles by plastics. We use plastic instead of metals, for example, or glasses. So this is just to say, it is a simple example, just to say that polymers are not polluting materials and contributes to the reduction of CO2 emissions. So now let's get to the bottom of our subject. We will try to show what is the relationship between polymers and COVID-19. Recently, every news bulletin starts with the coronavirus. Stopping it is perhaps currently the most important task in the world. And the virus that causes the COVID-19 disease appeared at the end of 2019. And in 1 year, I say in 1 year, after 1 year, it infected and killed people. And here I show the number of persons infected and killed. It is very, very high. And according for example, this study of Fatmi et al. And other researchers, of course, until today, the best solution remains prevention. How? By social distancing and disinfection, and of course with using masks. Yeah, the disease is spread from person to person by small droplets from the mouth or nose when the infected person breathes or coughs. As you know, a person can become inhaling these droplets or by touching contaminated surfaces and then touching her or his mouth, nose, or eyes. What is the solution? There is two things which are very important in the protection from the virus. The first one is disinfection of hands, and the second one is the wearing a respiratory protective device. And as you can see, all these things are made from polymer or from plastic. More than these protective device or simply mask are very important, although they can't prevent an epidemic or pandemic. They play an important role in prevention. So, if I ask you one question, do you know that face masks have typically several layers, mainly polypropylene? Polypropylene is polymer or is plastic. As PP microfibers are hydrophobic, skin-friendly, and non-allergenic. And do you know, more expensive protective gear, which follows the contour of the face better, are mostly made from polyurethane. And polyurethane is also a polymer or plastic, while the nano and microfibers of carbon filters are made by the carbonization of polyacrylonitrile. And this is also a polymer or plastic. And as if I ask you, do you know the elastic bands for fixing the box containing the filter and the transparent cover are all plastic products. More than another advantage of masks is that they prevent one from touching one's mouth or nose with a contaminated hand. This is also why it is very important to stress, as the media also does, the importance of frequent washing on the hands, preferably with a disinfectant soap. More of this. According to Parashar, for example, a surge in plastic demand during the pandemic is therefore primarily due to the manufacturing of personal protective equipment and packaging materials. So, if we ask what is the main materials used to do the personal protective equipment, we can say there are polyurethane, it is polymer, polypropylene, polycarbonate, polyethylene, and PVC. While the plastic used in packaging materials mainly consists of high and low density of polyethylene, polystyrene, and polyethylene terephthalate. Look here, I give you the use of mask. For example, on 1 month, consumption of facial mask and medical gloves has been reported to be around 129 billion and 65 billion respectively for 8 billion populations across the globe. In my opinion, it is very high quantity. So during this pandemic, during this year of pandemic COVID-19, we are in two places. We are at home because there was lockdown. So we are in two places, either at home or at hospitals. At home, we do shopping in our life, and the advantage of thick packaging during outbreaks is the possibility of being cleaned or washed, creating a protective barrier in food. In addition to increasing the packaging must be sanitized when arrived at home, and plastic packages can be washed with soap and water, or cleaned with simple disinfectant. They can be cleaned with solutions, for example, containing 62 to 71 of ethanol, percent of ethanol. We can use either hydrogen peroxide, or we can use also sodium hypochlorite for 1 minute. What about hospitals? In addition to personal protective equipment, most of the devices used to save lives are made totally or partially of plastic, such as respirators, thermometers, and COVID tests. And in addition to other more common and no less important items, of course, as you can see on screen, there are some pictures about all these items. And all these items are made with plastic. Another important application of plastic during the pandemic is a thickening agent in alcohol in gel, widely used for hand hygiene. It has advantages such convenience and ease of application, and avoids waste due to its high viscosity. Being composed of ethanol, 70%, it becomes more flammable, and the higher viscosity of alcohol in gel brings greater safety, besides having proven action in combating the virus. Okay, here, until now, I show you what is the role of plastics in this
Hello, ma'am.
Ma'am, we are not able to hear you.
it is what? Is there any problem?
Yes, ma'am, I think there is a network issue. You can start again. Now you are audible to everyone.
Okay. Hello?
Yes, ma'am. Yes, you are
Yes,
audible.
yes. Continue, ma'am.
Can you hear me?
Yes, yes, ma'am.
Yes,
We
yes.
can
And
hear
you can follow? Okay, you can see.
Yes, yes, we
Yes.
can see
Yes.
the screen.
Okay. Okay, sorry. I think the network is very bad. Okay. To remedy such concerns, we propose two solutions. The first one is
Yes.
recycling. Sorry? Sorry? It is okay.
Continue, ma'am. There is no problem. Your voice is clear.
Okay, sorry. And the second one is the use of bioplastic. Here I mean by bioplastic, of course, because in bioplastic there are many classes, and here I mean by biodegradable plastic. When we use biodegradable plastic, we will reduce the waste, and it is a promising solution to fossil fuel-based polymers. So start with the recycling. It has to be understood that plastic products, including face masks, oceans, and forests as plastic waste. There are many ways to recycle. of recycling. But here we talk about two ways. The first one is chemical recycling. It consists to come from macromolecules to obtain molecules or atoms. It's to manage mixed plastic waste into valuable products such as fuels and chemicals, would certainly help in achieving circularity. The second way is mechanical or physical recycling. Following the sterilization of infections, plastic waste must be incentivized with policy formulation to contribute towards the circular economy. And contaminated residues such as single-use personal protective equipment are considered infectious waste. And in this case, I say in this case, thermal treatment are safer. Why I talk about because virus can't resist at high temperature. And when we use mechanical recycling, we must use for manufacturing, for example, extrusion, injection molding, Brabender, etc. And it can do it with at high temperature. And mask use may even be considered hazardous waste. In this case, physical recycling, which typically means extrusion in the melt state around and sometimes more than 180 degrees C, could be a safe way of disposal as well. So, according the second way, no, it is the use of biodegradable polymers. What is the definition of bioplastic, of biopolymers? Biopolymers are polymers produced from natural sources, either chemically synthesized from biological material or entirely biosynthesized by living organisms. According to Morganti et al., it is proposed to produce natural polymers such as chitin and lignin. Chitin is a biopolymer which can be, for example, obtained from seafood waste. Lignin also is a biopolymer which can be extracted from vegetable fibers. It's obtainable from waste materials and may be used to produce biodegradable surgical masks. And according to this study, it seems possible, in fact, to make surgical mask by the assembly of 4 or more biodegradable layers, alternating hydrophobic and hydrophilic layers with films able to avoid the passage of microorganisms and viruses. Thus, on the one hand, this proposed surgical mask could avoid plastic waste and the passage of viruses, eliminating also the irritative phenomena caused by the actual masks. It means the mask made with the polymer, petrol polymer, or synthesized polymers. Okay, as conclusion, what I can say? I can say that we can deny, it is obvious that plastics are very, very important in our life because they are needed for sustainable development and they have properties that other materials don't have. However, we should use them responsibly and where they are needed to improve the quality of our life, prevent a climate catastrophe, and if necessary to stop the spread of contagious disease, including now the COVID-19. Further, the research and product innovation in developing eco-friendly and reusable personal protective equipment and carry bags made of bioplastics with higher recyclability should be encouraged. The third point, I think it is very important. It is about educational curricula as not planned to improve consumers' behavior. Yeah, it is our behavior, attitude, and social awareness to take the plastic pollution menace. Like this, I finish my presentation. Thanks for your attention. And I take the opportunity here to invite you to participate and submit your abstract to our conference. Polymer and Mediterranean Fiber International Conference will be held here in Vijaya in September. And I share with you some pics from my town, Vijaya town. So beautiful town, I think. Thanks again for your attention. It is okay.
Yes, ma'am. Thank you very much, ma'am.
Thank
Now
you.
we are
Welcome.
going to begin answering the questions submitted during presentation. Participants, if you have any question, you can submit it in the chat box as already mentioned. If you have any question, you can submit it in the chat box.
Okay, there is one question on mask. So which mask is good? Hello, ma'am.
Yeah.
Yeah. So there is a one question in chat box.
I advise the mask with multi layers for and I think about 4 layers.
Okay. And one more question is there. Do these polymers that you have shown are biodegradable or not?
The mask, the actual masks are made with synthetic polymers. For example, polypropylene. Of course, there are some studies about biodegradable, but I think it is not on. We can use it now. It is just studies. And the mask we can buy. It is made. It is with plastic, synthesized plastic. Of course, it is better if we can use the biodegradable plastic.
Okay, now I don't think there are more questions in chat box. Participant, if you have more questions, you can just share with ma'am. I'll share the email address of ma'am. You can.
Vikram sir,
Contact.
can I ask one question if you are audible?
Yes, sir. Yes, sir. Yes.
Yeah, it was a very nice presentation, Professor Dalaila. I have one question. What would be the life of surgical masks which are made from the biopolymers?
Sorry?
What would be the life of surgical mask made from biopolymers?
When we use biopolymers, of course, when I talk about biopolymers, of course, you have to know that there are biopolymers degradable and biopolymers which are not degradable. And here I talk about biodegradable polymers. Okay, and of course, the degradation rate it is very high compared to synthesized polymers.
But with its use, it can be degraded, right? The biopolymers.
Yeah. When I say biodegradable, it is biodegradable. Yeah.
So will
It
it
will
affect?
be there will be decomposition owing to microorganism.
Okay.
Is there any question from the participant side? Is there any question? Okay. Now it's time to listen our second guest of today's webinar. But before starting, we would like to hear his introduction and achievements from Dr. Vikram Pandit. Over to Pandit, sir. Am I audible?
Thank you, Vaishnavi ma'am. Yeah, there are more questions now in chat box, but I request you to please ask these questions after this lecture. Okay, we'll have a question answer session after this lecture also. Okay, so our next speaker is Dr. Swapnil Sonone. Dr. Swapnil Sonone did his master's in organic chemistry from North Maharashtra University, Jalgaon, and PhD from ACSIR NCL Pune. His thesis title during the PhD is Fluorescent Polymeric Microbes for Applications as a Solid State Multicolor Emitting Materials. Sir's area of research interest are small organic molecules and fluorescent dyes, heterogeneous polymerization, development in decorative and color polymers, water soluble polymers, optical sensors. His teaching research interests are chemical education, then descriptive research, case study, survey, finding outcomes, and current situation on these COVID-19 problems. Sir also have academic excellence and fellowship awards in his credit, such as excellence recognitions from Florida University, USA, award of international travel grant from Sir DET, Government of India, for attending a polymer conference at United Kingdom. Sir did two postdocs. One is in South Korea and another is in USA. Sir is also currently mentoring a PhD students, master students, and also a graduate students. With this brief introduction, now I request Dr. Swapnil to start his presentation.
Thank you, Dr. Vikram. Am I audible?
Yes, sir.
Yes. So it is pleasure to have with you all. Good afternoon to all. Very good afternoon to all. Special thanks to the organizers, Dr. Raut, Mr. Pawar, and Dr. Vikram. And I welcome everyone, eminent speakers already there, like Dr. Vargakar sir, who was my mentor during my PhD, who was my DAC advisor. So I welcome sir. I welcome Dr. Dalila. As well as I welcome all the dignitaries present in the seminar, students, faculty, fellows, and friends. I think since the first talk from the Dr. Dalila was, of course, quite interesting, and she almost covered many things regarding the polymers. So I hope that my talk will not be overlapping with her. But then, since I am now little bit relaxed because she already introduced you all what is the polymer and etc. etc. Okay, guys. There are some misconceptions about the polymers and polymeric material. That is what I will try to explain. And I will convince all of you that, yes, without polymer, several things cannot be completed. So with this, I will start my presentation. Before that, let me talk about the content what I am going to discuss today in this webinar. Since the title is Role of Polymeric Material During the Pandemic, I will cover introduction, not brief, but it's very short. Like, yeah, already IQA coordinator also explained. I was very happy while listening him. Then Dr. Dalila also explained. So I'm not going to have much time on this. Then I will talk about how the life without polymer or plastic material, is it possible? If it were possible, then what we used to do, or what our olden days were like without polymer, and how the polymer came in the focus. Then later we'll talk about the potential uses of polymer currently, how it is effective in the current situation, and how it is helping. And at the last, I will also have a look on how the polymer pollution is affecting in our sustainability as well as our day-to-day life. So in fact, I am also happy to share that, like as Dr. Vikram said, that what I do. So this is a couple of things we do, and this is my recent outcome with in collaboration with Dr. Shlenov, Florida State University. In fact, this is another outcome where this is the book chapter. In fact, I wanted to have a look on how the polymer composite material can be used for the water purification, etc. And here we worked on the charged polymer. If you are interested, you can go ahead and have a look on that. At the same time, I do teach in the college, so I feel my responsibility to build our nation by incorporating several research-based material or research-based problem, and at the same time, general awareness in my students, UG, PG students. So what we do, we promote them for the education, especially in chemistry as well as in multiple science branches. We do study of their like let's say we do demonstrations, and then we also study some reactions during the practical, etc., etc., and then we formulate the data, and then we bring the outcomes. In fact, in the last year, we all, like now also, we all are facing the problem of this current COVID-19, which is not only affected all the field almost, but the education, which builds the nation, which affected very highly. But since the technology, I should not say 100%, but since the technology is helping there, we are at least reaching to some of the students and getting, teaching them what is being going on. So that is what the last year, in fact, Dr. Vadgavkar sir is there, so I should highlight that Dr. Vadgavkar sir emailed something that there was a requirement from ACS regarding what is the problem going on in the teaching, what students are facing, are we really engaging them in the teaching, etc., etc. So I took this challenge and call, and then we have had some survey from the couple of students, and we try to understand their problem, followed by some solutions. This paper was in collaboration with one of my friends in the Cloud State University, and then we compared the their students' feeling and my students' requirement, etc., etc., and this outcome is here. Okay, so far this is what my research that we interested. But today, as a material and organic chemist, and as a polymer and material science chemist, a growing chemist, I should say, because I recently started my career, I would like to convince you all that, of course, polymers, without polymers, and how polymers. So I'm going to answer a couple of questions, and I'm going to leave a couple of questions to you all also. Okay, so to begin with, she already said that, so I'm not going to go in detail, but then I should say that what is polymer? It is nothing but what? It is a long molecule, macromolecule we should say, where there is small organic or inorganic molecules connected chemically. In fact, there are supramolecules or etc., etc. I'm not going to go in detail, but in short, just to show you all that small molecules will be connected through some polymerization technique, and you will get a long chain of polymer, which will be either long, short or etc., etc. Okay. In fact, since the title is here, polymer oblique plastic, can we call plastic as a polymer? Do we say all the plastics are polymer, or do we say all the polymers are plastic? So to answer this, plastic material is a compound of polymer plus additive. That should I say that. In fact, the additive is nothing but the material. When you add into the polymer, then it changes the property, and then you can mold it, you can reshape it into the valuable added product. For example, the things you use in the home. I said the things you use in the home means you use several things that is made up of the polymer as well as a plastic. Basically, they are thermosets and thermoplastics. Thermosets means, again, if you melt that polymer, you cannot again so it's very difficult to melt. It's very difficult to melt this polymer, because once you heat it, it changes the shape and you cannot recover it. Whereas thermoplastics, then you can melt it, and then again thermoplastics are semi-crystalline and amorphous, and these are a couple of examples, that PET, polyethylene, polystyrenes, and we'll be talking step by step what all things and what are the applications being in the day-to-day life. Okay, so I hope you got the conclusion of this slide, that polymers are macromolecules, plastics. All plastics are not polymers, but yeah, so whatever we discussed. Okay, am I audible, Dr. Vikram? Am I audible?
Yes, sir.
Yes, sir, you are audible.
Yes.
Yeah. So let us understand that polymers can be natural, or you can prepare in the lab. So natural means what? Again, nature itself gives, like it's a Mother Earth also gives us several polymers, like they are biodegradable. You can also prepare polymer in the lab as well, that we call synthetic polymer. So the polymer you get from nature or living being, which called is natural polymers and the synthetic polymer that you prepare in the lab by chemical reaction. In fact, these are the examples of natural polymers where you can have full of our body is made of with the biopolymer. I should say that everyone has DNA, and then I hope I should not go in detail. Okay, rubber that we get from plant, natural, the cellulose and the wool from the animal. In fact, these polymers, of course, they are biodegradable, they are non-toxic, they are mechanically similar to the tissue to be replaced, which means what? We can replace our, let's say any fracture is there. I think this is a nice research going on in developing country, and in fact, I do had a couple of presentations also in during this pandemic as well as in the US. Okay, these are highly porous material. On the other hand, synthetic polymer, as I mentioned, that you can prepare in the lab, and they do have several applications like high performance polymers, we can call them, like etc. Like here Teflon, nylon, or polyester. Okay, and well, you can manufacture them easily. You can do the processability and develop different product, and with the reasonable cost. So to summarize here, what polymers? They are lightweight. They are available in the variety of composition. And one thing, let me note down here that if you change the composition, you get the different property, and you get the different property which will have different application. So this is how our polymer. Okay, and you can be easily it can be easily manufactured into products that, as I said, the cup you use, plastic cup or cloth, let's say polyester, or any cross-link material, or let's say any rope, or etc. Okay, this is what. And in fact, when you have any biopolymer, let's say cellulose, and if you do some chemical synthetic reaction on that, we call that as a semi-synthetic polymer. Okay, so broadly, polymers can be naturally, can be synthetic, or can be semi-synthetic. Okay. Now, I just wanted to remind you all that in the olden days, since the polymer discovery started from 18th century, in the olden days, we all know that, like, what was used before polymer or plastic. So, of course, everyone might be aware or familiar, but as I was suggested by organizer that I will be having several audience like from different backgrounds, like chemist, microbiologist, physicist, etc. So I just want to go in deep here and just to let you know all that. Wood, metal, glass, and ceramic. In fact, animal-derived materials such as horn, bone, and leather was used in the previous days. As of course, in someone's home also will be there, that is. And then look at here. This is what, like a metal, then the wood material, and then the ceramic for the storage. And let me clear everyone that if I want to carry this this pot from somewhere, and if I have some other bucket which is lightweight, flexible, it is good, I will choose for that. So even though this material was there in olden days, the problem was what? The storage problem, as well as since it was heavy and fragile. Okay, since this material used to be molded with moldable clay, which was mixed with glass, and that was used, but then the containers were often heavy and fragile, and that is why I tell you, we don't want to have a high or like high weight material. So there were like kind of discoveries were going on, and then in fact, this natural material from the bark of rubber tree came in picture, which we call gum or latex resin. Then when this started to use that resin, but again the mixture was very sticky and moldable, but not useful for storage. You can imagine that you have a chewing gum in a pocket, and after some time, if you just remove this, you are in a hot temperature, and if you moving somewhere, and if you remove that chewing gum, then you see that it becomes very sticky. Okay, so it's kind of natural rubber was there, but then there were also challenges. So in 18th century, the great scientist Goodyear accidentally discovered rubber. That rubber he added into the sulfur, and the hot add the sulfur into hot crude rubber, that reacted, and it made flexible rubber, which again upon cooling become elastic, and that's how the polymer came into picture. And then later on, several discoveries started, bakelites, resin, etc. Okay, so this is what about the olden days and what was used before polymer. Now, as I said, synthetic polymer can be prepared in the lab and natural polymer can be obtained from the nature. So let me have a question here again. How is synthetic plastic created from the crude oil, or how the polymer material is produced? Everyone might be familiar about crude oil. That is, we obtain from fossil fuel, and then at fractional distillation, we get several components, naphtha, paraffin, etc., etc. This material again can be reacted into useful material like plastic, resin, fiber, etc., etc., using these techniques. Which techniques? These techniques: addition, condensation, heterogeneous free radical polymerization. In fact, nowadays, advanced polymerization techniques are used for development of smart material. I'm calling it smart material means the material is kind of stable, it has good mechanical strength, good thermal stability, flexibility, etc., etc. Okay, so I hope I could convince you all that the polymer material can be produced by this, like synthetic material can be produced by this couple of polymerization method. Again, you can use this method for the requirement of polymer you want. For example, if you want to have a paint in your home, you can use emulsion polymerization or precipitate or suspension polymerization or solution polymerization. If you want to have sheets or if you want to have any other kind of thing, you can select this polymerization methodologies. All right. Let me have one example here and ask again a question that, do the polymers contribute in sustainable development? So let's see. This is a picture of, one is picture having wooden chair and another picture have plastic chair. Now I want to make a chair, like I have a function in my house and or I just want to, yeah, I want to have a couple of chairs and I need a chair. So what I'm going to do, I'm not going to go and cut the tree. Instead of that, I know that the synthetic polymer material available, I can just have, in fact, it can be recyclable. So I can have these chairs, couple of chairs with multiple color with a nice decoration. They will be lightweight, they will be flexible. Even if they break, I can again go to the somewhere and just submit it for recycle, and again and again I can. It will have long life. Well, on the other hand, I have to cut tree. So if I have to cut tree, I don't want to cut tree. I hope you answer if you got the answer. Again, let me clear. I can use polypropylene, which is again the thermoplastic. I can have several usable products out of that. In fact, this different polymer product. So I don't want to go for the natural sources like, in fact, tree or like tree. I don't want to cut the tree. Okay. Whereas I also don't want to go to glass or metal or etc. because of the cost, because of the processing temperature, and because of their different properties. On the other hand, polymer which have low temperature, you can do it processing, it is lightweight compared to other materials. Okay guys, so this is what about something else I wanted to convince you all that yes, polymers can be a good candidate as a sustainable development. Now, look at the pie diagram where the plastic is used. I can promise you all that, or I can assure you all that polymer is everywhere in the world. It's kind of like a part of our life, like the packaging the food or things you pack in the polymer. You use textile, even the cloths or industrial machinery or transportation where we use the polymers. So this is a pie diagram which explains that 35% goes to the plastic packaging, then 13.5 go to textile, etc., etc. Okay. In fact, they do have polymers. They are outstanding and like very potential candidates. They do have applications in coating, hydrogens, conducting polymer. They can be used as a drug delivery. They can be used as a fire retardant polymer or flame retardant polymers or etc., etc. Okay, guys. So in fact, the cosmetic formulation also contains polymers, and these are the reports of couple of publications came from 2000 to 2019 on this polymer applied in cosmetics, where the 64% contribution in the cosmetics comes from the natural material. Okay, so this is what about polymeric materials application in our day-to-day life and how polymer is efficient compared to other materials. Obviously, every material has its unique property, but at an advantageous material, polymer is, of course, due to the processability, lightweight, mechanical stability, etc., we use them. And we don't want to complicate our life, so we go for easy solution always. Now, the real time to talk about polymers and their advantages during the COVID-19, their contribution, I should say contribution in the COVID-19. I don't want to wear a PPE kit which is made up of the metal, and that it will be difficult for me to move here and there. So there itself it says that PPE kit can be prepared by polymer, which is flexible. You can wash PPE kit, etc. Before going to that, let me remind you all that polymer formulation can be used for coating the surfaces. What surfaces? The surfaces we use every day. For example, if you go to hospital, if you go in wherever, right now we all are in home, but by mistakenly if something goes wrong, we go to hospital, and then what happens, you all know that we have to take care of everything. So what I'm trying to convince you all here, there are several things, let's say doorknobs, switches, personal protective equipment, wooden or plastic surfaces that we touch always. And this is one main reason the virus spreads. Of course, it spreads through the coughing or sneezing or etc. in the contact, when you come to the contact with some infected person. That is what we, obviously that is also matters. But when one of the modes of virus spread or any microbial community spreads, which is mainly through infections, and that infection is due to what? You touch the doors, you switch the doors, like you touch the doors, and the plastic surfaces. Okay, what if I have a coating on that? If I have a polymer which is which is again antimicrobial or antiviral or antifungal, if I coat it on that, then what will happen? I hope you got my answer. If I coat it there, then of course that will kill the bacteria or any microbes. And still there is nowadays so much development is going on, and this will clear from this picture. These are the microbes. They are again harmful to all of us. Like we are right now facing the problem. These are the biopolymers. We have antimicrobial agents on that, and this is what the mechanism where the microbes attack on the surface, and then the charges on the polymers will kill the it will break the material inside the virus or bacteria. And this is what the things that we use from the polymer. I will talk detail about it later. But if I have to show you the research publications in the field right now, it's from 2010 to 2020, and this talks about antimicrobial material. In fact, look at the polymers. It's more or less like kind of growing. Like polymer material also important in case of as a coating material on the surfaces to avoid these infections. Okay, so there is high demand from research and industry to develop high performance polymeric coating material which could kill or stop the spread of pathogen. So this is what one of the most important application of polymer material in the current situation. At the same time, charged polymer also playing an important role since they have a charge, of course, and also some other hydrophobic mass will again play a key maker role in controlling the growth of these viruses or bacteria. So how? So this polymer solution will be in the form of emulsion, antibacterial or antipathogenic emulsion will be coated on the pristine cotton, like the cloth or the thing you use, and then later on this will be exposed to the bacteria, as you can see here. So what it will do, the charges as well as the hydrophobic part of the polymer will damage, or it will it will create a problem to the virus, and that's how you can control the growth. That's how you can save the life. Okay, so polymer coating would be the great warrior to fight against the COVID pathogen. That's what I could convince you all here. Dr. Dalila also said so many things about plastic, and we all know that plastic material is being used in the medical or in the current situation. So how? So we'll talk about how the plastic in a medical applications, where and how, and what are the products of plastic. Obviously, We can use them medical disposable and gears. We can use them in prosthetics. You can use them in a medical device. You can use them treatment as well as equipment. In case of medical disposable and gears, the syringes, the blood bags, the clothes, the PPE kit, of course, and the non-mask as well as masks can be prepared by polymers. And it was already discussed in the previous lecture, previous talk, that you can use variety of polymer for preparation of this material. In fact, when you talk about prosthetic, several polymers can be used for implants and prosthetics. In a medical devices, they can be used as a diagnostic and surgical devices. And of course, the polymers can be used to coat the drug in medical sterilization and trace. And here I can again conclude that the polymers that we use, for example, polypropylene, polystyrene, low density, high density polyethylene, and polyethylene terephthalate can be used as a packaging material. Like I was reading a couple of things, like I understood that in a European country nowadays, everybody is in the pandemic in a home quarantine. We are also in home quarantine, but in India, especially, we don't go for, like in our area, we don't go for packaged food and etc. etc. But in out of other country that I was reading, that I understood that several people are moving to the packaged food, and there again the demand of package polymer for the packaging is increased. Okay, so another again mask, face shield, and take out containers like PP, polycarbonate, polystyrenes. There you can use this polymer material for development. And sanitizers, bottles, apron, gloves, and goggles by polyvinyl chloride. You may say that how hand sanitizers? You know, emulsion. In emulsion, you may have any antibacterial or any antifungal reagents connected to the polymer or encapsulated in the polymer that will have uniform suspension or dispersion or emulsion that can be used as a hand sanitizer also. In fact, plastic bottle we drink in a water, we drink for water. I don't want to carry metal can since it is lightweight, etc. It's weight, and but I can use the bottle. I hope you are getting what I'm trying to explain. And of course, for the garbage bags and bins and gowns, you can use the polyethylene, which is low density polyethylene. So this slide summarize, this is the polymer outcome or contribution in the current pandemic. And when I move to the next slide, this everything explain that, yeah, you are already wrapped up with the polymer. Polymer is protecting you from the infected environment. For example, face shield, respirator gown, etc., etc. So I don't want to go in deep there because it's already been explained. But I would suggest you, if you are going here and there, let's say in hospital, because few of my students goes to work here and there, so I suggest them, like if you want to have this PPE kit, please follow this procedure. First, you have to wash your hands. Then you wear the PPE kit, this kit, gown, your apron. Then you put a mask. Then you apply your face shield, and then you wear the gloves. So these are the stages suggested by suggested to put on PPEs for healthcare setting. At the same time, if you are done with your work, and if you are then this is what the removing is suggested. First, you remove the gloves. Then you remove your this face shield. Then your PPE, like your apron or your gown. Then you remove your mask, and then you wash your hand. That's how you can stop the infection. Otherwise, then there might be some chances that if you yeah, we do suddenly. I see so many people, they will wear this gloves, and then they will hold their mobile also. So please avoid that. That is again kind of suggestions here. And then like a previous slide, this slide also explained that polymer have contribution in the current situation. So polymer alone or as a composite material is playing a major role in pandemic situation to control the growth or spread of pathogens, either in the form of solution, in the form of spray, in the form of film, fiber, etc., etc., or even packaging material. Okay, guys. So this is what about the role model of our polymer is being used in the PP or in the current situation. Now I am at the last part of my talk. I hope Dr. Vikram, how much time do I have? Should I continue?
Yes, sir, you can.
Okay, okay, thank you. Yeah. So I convince you all that polymers, then how do they prepare, and then what are the applications and what are their applications in a current situation. But you know, again, the misconception is what polymers create pollution, polymers does this, polymer does that. I don't think polymer jumps from here and there and does the pollution. So what? I just have these questions for all of you. Who is responsible? I don't have answer for this. You guys, you all can think about that. Would systematic planning management help to control the pollution? See the picture here. Whatever, if someone like I'm going to quote that in the science paper and that I'm going to present in front of you couple of minutes ahead. Whenever we like someone goes to beach, they will throw polymer material somewhere. Even right now also, look at this picture. What is this? So the systematic investment will matter here. And since from last year, this was a sudden it's very dangerous situation created, and everyone moved to prepare material that will help for people or society or etc etc. And due to the high demand during the pandemic, to avoid the shortage of PPE material and medical equipment, plastic polymer production has been increased suddenly, which again resulted in a pollution as well. Okay, so let us have a couple of slides at least. How can we reduce the pollution? What should we do? And etc. etc. So now, before going to that, I want to share you all that there are a couple of polymers we use for day-to-day life applications, and we are kind of confused that okay, this polymer will be recycled. Okay, whether this polymer, what is like? Let's say I have a bottle, I have a cup, and I want to find it out how can I distinguish that the cup is made up of this polymer and the bottle is made up of this polymer. So are the polymer structure that I am going to tell you all this is, and then this is the material being used. But how do we remember that? So this is what I would like to tell you all that. If I have something like PET bottle, you turn that bottle down and then you look at there will be this symbol which corresponds to what the material is made up of, the PET, polyethylene terephthalate. If I have polyethylene high density, then the number will be 2. If I have polyvinyl chloride, etc., etc., etc. Guys, the recycling, of course, we should recycle everything, but there are challenges as well in the polymer recycling because of the property, the purity, and the cost. And we will discuss in the next slide, but please, just to convince you all that we can identify polymer by this code. In fact, if you have a code number 7, this material includes combination of polymers. This is like non-recyclable material, like nylon or some other plastic. So now let us see first what is the global production of polymer of plastic. And this was being again discussed by Gear. He is trying to convince the data or show the data from 1950 to 2015. This is in millions metric tons. This is what he says the global production of and uses and fate of the polymer resin, synthetic fiber and additives. What he says, as of 2015, approximately 6,300 metric ton of plastic waste had been generated. Please listen carefully. 6,300 metric tons of plastic being generated, around which 9% of which had been recycled. 12 was incinerated, 79% was accumulated in the landfill or natural environment. This is what the wondering slide, that even if we have 6,300 metric tons of plastic, we could just recycle 90% of which. The 12% was incinerated, and then remaining like maximum part was accumulated in the landfill or natural environment. And similarly, the graph also, like he also shows the graph, like what will happen when we compare, or if it goes like this, what will happen if it keeps on growing, what will happen? So you can see here, this is the millions metric tons, and these are the years. The black line indicates primary waste was generated after polymer production. The red line indicates all waste was discarded since the material was generated, and then all material was incinerated and all waste was recycled. What this graph is telling? See, the generation will keep on growing. It will be 25,000 millions metric tons at 2050. This is a cumulative plastic waste generation and disposal. This is what. Later, then all waste will be discarded up to what? Near about 12,000, means 50% will be discarded. But how it will be discarded? Some of them will be incinerated, some of them will be recycled. So this is a kind of serious issue when we have recycling. You know what happens sometimes, the polymer will be cheap, but then the recycle will be costly. So they just straightforwardly go to the landfill or natural environment, or etc. They do. Okay, and we are here right now. It will grow like this, and then near about only 8,000 metric tons will be recycled. So the number 25,000 and 8,000, you can see here what is the recovery rate, recycle rate, and what will be the generated rate. Now, in the back slide, I was telling you about the cumulative things that the polymer will be generated and will be discarded. And it was again 6,300 metric tons, and then only 900 were recovered or recycled. Now here in the current situation, as we all know that the requirement were huge because we wanted to save the life. So there was high demand to generate plastic material that will be useful for packaging, PPE kit, etc., etc. So this paper talks about accumulation of plastic waste during COVID-19. As you can see here, as I discussed you, during the pandemic, the protection PPE demand increased, simultaneously pollution also increased. The reason is what? The quantity. I'm just talking about the China. Here it is mentioned. So single face mask production in China sold 116 millions per day in February, and which was again 12 times the usual quantity. This is again one of the main reasons that polymer plastic again pollution is increasing. In fact, as I told you that people are in home, they don't want to go outside because we all know that what is the problem. So they are ordering packaged food. So since they are ordering packaged food during the lockdown, the delivery packaged stocked out meals and home deliveries again contributing to the 1,400 tons of plastic waste during only the 8-week lockdown of Singapore. This is what only Singapore. Okay, if we imagine about the whole world, then the number will be somewhere else. In fact, the waste management practices have lots of pressure to manage this waste. So what they are doing, because of that, some of the material will be mobile incinerated, some of them are directly putting in landfills, some of them are directly burning, local burning we call it. And the improper, if I say improper disposal of just 1% of face mask translates more than 10 millions of items. Okay, so what I'm trying to convince you all that polymers are warrior, same at the same time the pollution is also creating because of them, but then the systematic investment and systematic planning should be there. Okay, this is what again I think this might be the last but two slide where the management and recycling of plastic waste during the COVID-19 is showed. As Dr. Dalila also said that there are two types of people. Some of them are sitting in few are in home, so they will generate waste plastic. Some of them are in hospital, so there is hospital waste plastic. You can see here there will be less contamination or little bit contamination. We should not say that, but there will be less contamination compared to the material which is being generated in the hospital. That this material the generated from hospital home can be recycled. Initially they will clean, etc., etc. A couple of processes are there. Some of them will be directly dumped in the landfill, and this is what. Okay, guys. Moving to the last slide, where the recycling, is it economically? viable? This is what the question I want to ask. And there are two methods. I am just trying to explain you all that. The recycling of polymer by mechanical or by organic recycling. Okay, so I think I have convinced you all that what is being discussed and not. And let me have a conclusion over here that polymers are potential candidates used almost everywhere in the human needs. And I know that, like we all know that we use polymers always everywhere, but we complain. And that is what kind of hurt, that we use them and we again complain them. No, they are creating pollution. Why? You all know that why. Okay, so again, modification, if you modify that material, it changes its property. In fact, when I was in NCL, maybe Dr. Sir might be remembering that we have incubations, innovation center in NCL. When I was in 2014, there was one boy came. There was an event, and there one person came and he wanted to recycle polymer. So he had showed a couple of pictures that they were collecting polymers, polymeric, waste polymeric. Then they will segregate it, and then he was preparing some kinds of useful material of that polymer material. Okay, so such kinds of mentality should be there, that we always blame government, or we always blame some other people that no, they don't give funding, etc., etc. But we should also little bit to start something that kind of responsible person. Well, there will be new challenges, like I heard that not only me, everybody heard that there is some other mucus kind of thing, like fungus is again generating because of this. This is again new disease. So these kind of challenges are there, and I'm sure polymer will again help there. Because as discussed, a charged polymer can have ability, and there are new discoveries still going on. We should use polymers product, of course, but then the systematic management should be there. We should not throw it somewhere. If you go to beach and move here and there and you throw, no, please don't do that. Because it again goes to the sea and then the recycle. Okay. In fact, in Maharashtra also, not only Maharashtra, all over India, we see poor animals. They will eat plastic. They will die. Poor like etc. etc. Don't want to go in deep, because we all know that things. Okay. Yeah, it is recommended to use biodegradable polymer. In fact, some of the biodegradable polymers are very outstanding, like polylactic acid. So we should use kind of biodegradable polymers, and even if we use non-biodegradable polymeric material, we should try to send them to recycling material or try to store them in a safe place so that it will not be dumped to the environment. Okay. Focusing on better recycling and challenging things going on, because as I said you that polymer cost, making cost is less than the recycling cost. That sometimes stops recycling. And well, general awareness is very important. So that could control the plastic, ultimately save the life. So with this, I acknowledge and I thanks everyone for your kind attention. These are a couple of my collaborations that we work. And I highly acknowledge my college president, management, principal sir, my department of chemistry, and my students. They inspire me always. And then thank you all of you for your kind attention. And thank you again the organizers and principal sir of Desai College for giving me an opportunity to share whatever I have a little bit. Thank you.
Thank you, sir. If anyone have any question, please submit it in the chat box.
Okay, Swapnil sir, there are few questions. First question is there any limit for recycling the biopolymers?
Yeah, so it's a kind of good question. Is there any limit for recycling biopolymer? See, if it is biopolymer, then it can be recycled easily. Okay, either it can be recycled by microbes, or it can be fermented, or it can be used as a compost material.
Okay, then one more question is there. Do these biopolymers made materials are useful for protection of viruses like COVID-19?
See, these biopolymers, if you have any any responsive material in that, let's say antifungal agent or antiviral agent, if you incorporate into that, then obviously they are going to be the again role player. But only we have to worry about their some other properties like temperature and the sustain their feasibility in the climate. Yeah. So as I told, modify the polymer, get property whatever you want.
One more question is there. Is it safe to use mask for children below 5 years of age?
Oh wow, that's the kind of question. Uh, I'm sorry to say I don't have answer for that, but then yeah, I don't have answer for that. Yeah, but we
It's
should take
like
care of them. Always, we should
yeah.
take care of them.
Yes, yes. That's good answer. And is there any efficient method to degrade all these polymers?
See, degradation means like right now one of like my PhD student, he wants to develop a biodegradable material by incorporating bioplasticizers. Bioplasticizers means he like yeah, whatever sir is there, I should not tell anything in front of him, but then yeah, we can degrade the material by incorporating the biodegradable plasticizer obtained from the nature. At certain level, it will be degraded, but then later on, we have to again. And as you all know that if you dip some polymer in, let's say you use any polymer, and if you just put it inside the sunlight, as time goes, it degrades.
Yeah.
Dr. Vikram,
Okay.
am I audible?
So now there are a lot of questions are there. I request participant to kindly communicate the speaker. The contact details are here. We can share it with you. You can email them. As we are like I think 10 minutes ahead of our schedule. So now I request Vaishnavi madam to give the vote of thanks.
Okay, sir. Thank you, sir. Thank you, sir and ma'am, and thank you everyone for attending today's webinar on polymers and current scenario of COVID-19. I would like to thank PGK Mandal, Principal of our college, Dr. Ganesh Raut, Vice Principals, IQAC Coordinator, in charge of Self-Finance Section, Devre sir and Shah sir for technical support. Also, I would like to thank scientists, professors, research scholars for attending this workshop, and most importantly, I would also like to thank all the student participants from all over the globe for attending this webinar. Thank you for joining us today and have a great rest of your day. Thank you once again.
The feedback link will be provided to you on your WhatsApp group. Kindly submit that link, you will get a certificate.
Pandit sir, some people are not on the groups.
Yes, yes, sir.
You can share here also.
You can share in chat box, Pandit sir.
Because few people are not joined on the group, but they joined the meeting.
Okay. Sir, if you have the link, can you share? Because it's in my mobile. Devre sir, do you have the link? I have already shared it on WhatsApp group.
I shared in chat box. Just check it.
Okay, sir.
Link is posted in the chat box of the Microsoft Teams. Please give your valuable feedback. After that, you will get a e-certificate for attending this webinar. If you have any query, you can contact on the given numbers on WhatsApp. Pandit sir.
Yes, ma'am.
Link is posted. Should we stop?
Okay, link is posted everywhere here and on WhatsApp group. There is a limit of 100 participants. Okay, so for today only 100 participant can get certificate, and rest of the participant can try it on tomorrow. Tomorrow they will get certificate.
Okay, sir. Thank you. Thank you all the participants. Now you can leave the webinar. Thank you for your participation. Just click on that red button and you can leave the webinar.
Jagtap sir, काय राहिले का?
No, it is okay. I think we can end the meeting now. Yes. Yeah. Thank you. Thank you so much. Thank you, Vikram sir, Vaishnavi madam.
Thank you, sir.
Thank you, sir.
Every sir. Thank you very much.